You know, it's funny. Every time I look up at a truly starry night sky, I can't help but feel that same sense of awe and wonder. It's like there's just so much out there.
It really is incredible, isn't it?
Yeah, and tucked away among all those twinkling points of light, could there be other beings on other worlds asking that same question? Are we alone?
It's a question that's captivated humanity for centuries.
And get this, there's actually an equation for that. Kind of. It's called the Drake equation.
Ah, the Drake equation.
And it's not about giving us a definitive answer. It's
Yeah.
more like grabbing all those what ifs floating around in our heads and trying to make some sense of them.
Exactly.
And that's exactly what we're diving into today. We've got a paper that uses this famous equation to, well, calculate the odds of finding another alien civilization out there.
Sounds fascinating.
So, ready to put on your astrophysicist hats and get a little cosmic with it?
Let's do it. The Drake equation can be a wild ride.
Hold on, before we launch into hyperspace, give us a quick sense of what this equation actually looks like. Is it as intimidating as it sounds?
It's surprisingly elegant, actually. It looks like this. N equals R star times FP times NE times FL times FI times FC times L.
Okay, I'm not gonna lie, that looks a little like alphabet soup to me.
Understandable. It's a lot to unpack.
But I trust you. Break it down for us.
No.
What do all those letters actually represent?
Each letter is a factor that contributes to that final N, which is what we're ultimately after, the number of detectable civilizations out there in the Milky Way.
Okay, so N is the big, mysterious answer at the end of the cosmic rainbow. I'm ready to start crunching those cosmic numbers. Where do we even begin?
Well, we start with stars. Our star represents the rate of star formation in our galaxy. Basically, how many new stars are popping up each year.
So like a galactic baby boom.
Exactly. And the Milky Way is pretty fertile. The paper we're looking at today uses an estimate of 2 new stars per year.
2 new solar systems, just like ours, every single year.
Yeah,
That's... Wow. Okay, so stars are forming all the time. But how many of them have planets orbiting them, like our own little cosmic neighborhood?
That's where FP comes in, the fraction of stars that have planets.
Makes sense.
And here's where it gets really interesting. Thanks to missions like Kepler and TESS, we've discovered that planets are more common than we ever imagined.
So we're not talking about a few planets here and there.
Not at all. We're
Right.
talking nearly every star likely having at least one planet in orbit.
Wow, really?
So for FP, we're looking at a number really close to 1.
Hold on, let me get this straight. Almost every star out there, and there are billions upon billions of them, has at least one planet.
At least one, most likely more.
You're blowing my mind a little bit here.
And we're just getting started.
Okay, if we've got all these planets, it makes you wonder how many of them could actually support life.
Right. We need to narrow things down a bit.
I mean, we're not just talking about any old rock floating in space.
Right. And that's where NE comes into play.
Okay.
The number of planets per star that could potentially be habitable.
Okay.
Think liquid water, a decent atmosphere,
my.
the kind of place where life, as we know it, might have a fighting chance.
So Goldilocks planets? Not too hot, not too cold, but how do we even begin to guess how many of those might be out there?
Well, we look for planets that fall within what we call the habitable zone around a star, that sweet spot where temperatures are just right for liquid water to exist on a planet's surface.
Okay.
And based on the latest research, it looks like roughly 20% of sun-like stars might have an Earth-sized planet right in that zone.
So for every 5 stars with planets, one of them probably has a planet that could, at least in theory, support life.
That's the idea.
But here's the billion-dollar question.
Yeah.
Does life actually appear on those planets, or is Earth some kind of cosmic fluke?
That's the million-dollar question, and it's where we step into even more speculative territory with the fraction of those habitable planets where life actually emerges.
And the paper we're looking at, what does it have to say about our chances of not being alone in the universe?
It's just a 1 in 3 chance that life might arise on a habitable planet.
1 in 3?
Yeah.
Those odds are better than I would guessed.
It's based on a couple of pretty mind-blowing facts. One is the speed with which life popped up on Earth after it formed. Relatively speaking, it happened pretty quickly.
Right?
Which suggests that life might be a pretty eager beaver when it finds the right conditions.
Life finds a way, right? At least that's what the dinosaurs taught us.
Exactly. And the other factor is the sheer diversity of life we see on Earth. Even in the most extreme environments, it makes you wonder, what if life on other planets is just as tenacious? What if it finds a way even in the most unexpected of places?
Okay, so we've got a decent shot at life arising. But what about intelligent life? That feels like a whole other level of cosmic lottery win.
It really is the next hurdle, and that's where FI comes in, the fraction of planets with life, where intelligent life actually evolves.
So we're talking civilizations that can build spaceships, write symphonies, invent the perfect pizza.
Exactly, though what constitutes intelligence on a cosmic scale is a whole other conversation.
Right.
But for our purposes, we're talking about life forms that develop complex thought, technology, and the ability to communicate across interstellar distances.
So how does the paper approach this factor? What are the chances of intelligent life actually developing on a planet teeming with life?
It takes a fairly conservative view, estimating FI to be zero point zero 0.01 or a 1 in 100 chance.
Wow. 1 in 100 planets with life. That makes you feel pretty small, doesn't it? Like all of human history, every achievement, every pizza ever eaten, it all comes down to this tiny little fraction of a chance.
It really puts things in perspective.
Okay, so even if intelligent life does evolve on a planet,
Yeah,
there's no guarantee they're sending out signals we can detect, right?
precisely. And that's where we get to FSC.
Okay.
The fraction of intelligent civilizations that develop technologies detectable to us here on Earth.
Right, so maybe they haven't figured out radio waves yet, or maybe their technology has advanced so far beyond ours, it's like trying to pick up a whisper across a stadium?
Or maybe, and stick with me here, maybe they just don't want to talk to us.
Yeah.
I'm not saying it's aliens, but
Or maybe, right.
but remember, this equation is just dealing with what's detectable
Okay.
for this deep dive.
Right.
Let's stick with the paper's assumption that 10% or zero point 0.1 of intelligent civilizations develop technologies we could potentially pick up on.
10%. Okay, so we're down to a tiny sliver of a chance here.
We are.
But there's still one more piece to this puzzle.
There is, and it's a big one. We have to consider L,
Okay.
the length of time, on average, that a civilization releases detectable signals into space.
So it's not just about being in the right place at the right time, it's about being in the right time for long enough to make contact.
Exactly. Think about it.
Huh?
We've only been sending out radio waves for about a century. That's a blink of an eye on a cosmic scale.
Right.
What if civilizations tend to flame out after a few thousand years? Or maybe they evolve past the need for technologies we can detect.
Or maybe they finally figure out how to travel faster than light and decide to take their galactic party on the road.
Who knows? But those are all factors that would affect L.
Right.
And the odds of us ever making contact.
Sure.
This paper, for the sake of this calculation, assumes a civilization might be detectable for 10,000 years.
10,000 years, that's an impressive run, but still a drop in the cosmic bucket, really.
It really is, and it makes you wonder, what event, what discovery, what catastrophe
Right.
could cause a civilization to go silent after 10,000 years?
Okay, I think I'm ready to stop speculating and start calculating.
Okay,
We've got all our cosmic ingredients, so let's bake this Drake equation cake and see what we get.
let's do it.
Okay, I've got my calculator warmed up and I'm holding my breath. What does the Drake equation tell us? What are the chances of another civilization out there sending signals into space right now?
Well, when we multiply all those factors together, the rate of star formation, the fraction with planets, and all the rest,
Yeah.
we get a result of 1.32.
So it's just over one, just one other civilization out there in the vastness of the Milky Way. That might be detectable. That's surprisingly low, honestly.
It might seem low, but remember, it's not saying there's only one other civilization out there, period. This is just a snapshot in time based on our current limited understanding of the universe.
So it's more like there's a good chance that at some point in cosmic history, we haven't been totally alone.
Exactly. There could have been civilizations that rose and fell long before humans even existed. And who knows how many more might emerge in the future.
Okay, that makes me feel a little less lonely.
Mm.
But it also makes you wonder, if it's statistically plausible for other civilizations to exist, even if they're transient, why haven't we found any evidence of them yet?
You've just stumbled upon one of the biggest head-scratchers in science, the Fermi Paradox. It's this intriguing contradiction between the high probability that other civilizations are out there and the fact that we haven't picked up a single alien transmission.
It's like the universe is this giant dinner party we know we were invited to, but when we
Yeah.
show up, the lights are out, the music's off, and there's not even a half-eaten bowl of chips in sight.
That's one way to put it. And there are a lot of theories about why the universe seems so quiet. Maybe Earth-like planets, the kind that can support life as we know it, are much rarer than we think. Or maybe intelligent civilizations tend to self-destruct before they figure out interstellar travel or communication. It's a sobering thought.
Or maybe, and stick with me here, maybe advanced civilizations have figured out interstellar travel, but they're choosing to keep a low profile, observing us from afar, like cosmic anthropologists studying an ant farm. Okay, maybe I've been reading too much science fiction.
It's fun to speculate, but let's come back to the Drake equation for a moment. It's important to remember that this 1.32 isn't set in stone. It's incredibly sensitive to even the slightest tweaks in our assumptions.
So what happens if we play around with the numbers a bit? What if, instead of being conservative, we go full-on optimist about the chances of intelligent life out there?
Well, if we bump up the probability of intelligent life evolving and the length of time they might be detectable, that 1.32 starts to look a lot more interesting. For example, if we assume a 1 in 10 chance of intelligence, a 1 in 5 chance of them developing detectable technology, and a lifespan of, say, 50,000 years.
Okay, I'm getting my hopes up.
Suddenly, we're not talking about one other civilization. We're talking about a potential 132 civilizations out there right now.
132, that's a whole galaxy's worth of potential pen pals. But I guess we could go the other way too, right? What if the numbers are even less encouraging than we initially thought?
That's the other side of the coin. If we use more conservative estimates, life being rarer, intelligence being even less common, and civilizations flaming out quickly, then the Drake equation might suggest we're alone, or very nearly so, in the vast expanse of the Milky Way.
So it's like this equation is both exhilarating and terrifying at the same time. On one hand, we might be part of a vast galactic community, and on the other, we might be the only ones at the cosmic party after all.
Yeah, exactly. And the truth is, we just don't have enough information yet to know for sure. But that's the beauty of science. It's not about having all the answers. It's about asking the right questions and constantly seeking new knowledge.
And it seems like we're on the verge of some incredible breakthroughs in our understanding of life beyond Earth. The paper mentioned some really exciting areas of research that could help refine our estimates, right?
Absolutely. We're talking about advancements in exoplanet surveys that'll help us pinpoint those Goldilocks planets with even greater accuracy. Then there's the field of astrobiology, which is all about understanding the limits of life as we know it and the possibility of life as we don't know it. And, of course, there's SETI, the ongoing search for extraterrestrial intelligence, constantly listening for any whispers across the cosmic ways.
It's like we're finally getting the tools we need to move beyond speculation and start piecing together the real story of life in the universe.
Exactly. And who knows what amazing discoveries await us.
Who knows indeed? This deep dive has definitely given us a lot to think about. If there really are 132 other civilizations out there, what do you think they're like? Would we understand each other? What would we say?
Now, those are questions for another deep dive.
You're right about that. Well, that's all the time we have for today's exploration of the Drake equation and the search for extraterrestrial intelligence. Thanks for joining us, and as always, keep looking up